we're going to evaluate the integral of the square root of tangent of x. So to do it, we'll need the following results. First, the integral of 1 over u squared plus 2 is equal to 1 over the square root of 2 times inverse tangent of u over square root of 2. And the second result, the integral of 1 over w squared minus 2 is equal to 1 over 2 square root of 2 times the natural log of absolute value of w minus square root of 2 divided by w plus square root of 2. The third result we'll need is the expression y squared plus 1 over y squared can be written as y minus 1 over y squared plus 2, and also can be written as y plus 1 over y squared minus 2. Now to see this, we'll just do one of these. We take y minus 1 over y squared and add 2. This is y minus 1 over y times y minus 1 over y plus 2, which is y squared minus 1 plus 1 over y squared plus 2. So minus 1 and plus 2 cancel, and we end up with y squared plus 1 over y squared. So now let's return to the integral, which is the square root of tangent of x. Our substitution is going to be y squared equals to tangent of x. If I square both sides, we get y to the fourth equals to tangent squared of x. And differentiating, we get 2y dy equals to secant squared x dx. From the trig identity, 1 plus tangent squared of x equals to secant squared of x. We see that tangent squared is y to the fourth. So 1 plus tangent squared is 1 plus y to the fourth, and that is equal to secant squared of x. So now plugging it back in here, we get 2y dy equals 1 plus y to the fourth dx. And then if we solve for dx, that's 2y divided by y to the fourth plus 1 times dy. And now let's plug that into the integral. The integral has square root of tangent x, so that's square root of y squared times 2y divided by y to the fourth plus 1 dy, which is equal to square root of y squared. We can take it to be y, and then times 2y, that's 2y squared over y to the fourth plus 1 dy. Next thing we want to do is to divide both the numerator and the denominator by y squared. And that will give us the following. The numerator, 2y squared over y squared is 2 divided by y squared plus 1 over y squared dy. I'm going to write 2 in the following way. 1 plus 1 over y squared minus 1 over y squared plus 1 divided by y squared plus 1 over y squared dy. Notice that the numerator is 2 because 1 over y squared minus 1 over y squared cancel. And now let's write this as a sum of two integrals. The first integral is 1 plus 1 over y squared divided by y squared plus 1 over y squared dy. And the second integral is 1 minus 1 over y squared divided by y squared plus 1 over y squared dy. And now we use result number 3. This, let's call this integral 1, and this is integral 2. In integral 1, we're going to express y squared plus 1 over y squared as, so the numerator is 1 plus 1 over y squared. The denominator will write this as y minus 1 over y squared plus 2. And then we'll do the second thing for the second integral, 1 minus 1 over y squared divided by y plus 1 over y squared minus 2. And now let's make the following substitutions for this integral. We're going to let u equal to y minus 1 over y. du is 1 plus 1 over y squared dy. And for this integral, we'll let w equal to y plus 1 over y. Therefore, dw is equal to 1 minus 1 over y squared dy. So the integrals now look like this. This first integral, we have du divided by u squared plus 2, plus, in the second integral, we have dw divided by w squared minus 2. And so we can use result 1 and result number 2 to evaluate these integrals. So the first integral is equal to 1 divided by the square root of 2 times the inverse tangent of u over square root of 2, plus the second integral is 1 divided by 2 square root of 2 times the natural log of absolute value of w minus square root of 2 over w plus square root of 2. And let's substitute. Now recall what u was. U was y minus 1 over y. So this is 1 over square root of 2 times inverse tangent of y minus 1 over y divided by the square root of 2, and then plus 1 divided by 2 square root of 2 natural log absolute value. W was y plus 1 over y minus square root of 2 divided by y plus 1 over y plus square root of 2. Now let's further simplify this. We're going to multiply both numerator and denominator inside the inverse tangent and the log by y. So this is 1 over square root of 2 times inverse tangent of y squared minus 1 divided by square root of 2y plus 1 divided by 2 square root of 2 natural log of absolute value y squared plus 1 minus square root of 2y divided by y squared plus 1 plus square root of 2y. And recall what y was. Y squared was tangent of x. Therefore, y is equal to the square root of tangent of x. So now let's plug that in, and our final answer is 1 over square root of 2 times inverse tangent of y squared, so that's tangent of x, minus 1 divided by square root of 2 times the square root of tangent of x, and then plus 1 over 2 square root of 2 natural log of absolute value of tan x plus 1 minus square root of 2 times the square root of tangent x divided by tangent x plus 1 plus square root of 2 times square root of 2 tangent, or square root of tangent x. And so let's summarize what we did and write the final answer. The integral of the square root of tangent x is equal to 1 over square root of 2 times inverse tangent of tan x minus 1 divided by the square root of 2 tan x plus 1 over 2 square root of 2 natural log of absolute value of tan x minus square root of 2 tan x plus 1 divided by tangent of x plus the square root of 2 tangent of x plus 1, and then we can add a c at the end. For more videos, visit www.mathprepvideos.com.